Thank you very much, Quentin. Garrison. All right. We have section 6.6 today. Focusing today on the angle bisector theorem, which I'll introduce in just a minute. So, this is the last section of notes today for chapter 6, which was a really nice, short and sweet unit. This is the last test. You guys have a review day tomorrow and a test on Friday. I think the review is going to be posted here in a minute for the test. And
it's already out.
Is it already out? Okay. But also there should be also posting, I think on Friday, maybe Thursday, I don't know. The final exam review is going to be posted as well. I'll talk about that in a little bit. There are two options for your review. You can choose which one you want to do. Today we have a little bit of interesting sort of proportionalities going on here today. It's contingent upon two triangles being similar. If two triangles are already similar, and so you can see here we have what she doesn't specifically say, but triangle ABC. So we have this triangle. Triangle ABC is similar to triangle EFG. See, this one's a little bigger, this is a little smaller, but they're similar triangles. And so what we have here are some special cases. If you have altitudes, now what is an altitude? An altitude is a line dropped from a vertex perpendicular to a side of a triangle. So an altitude drops perpendicular to the opposite side from a vertex. So we have these altitudes here, and it turns out that the following corresponding parts are also proportional to pairs of corresponding sides. And so I can, now this altitude doesn't happen to be part of these similar triangles. It's an added bit, all right? But we can say, hey, the ratio of these altitudes, so I can say the ratio of that altitude BD over this altitude FH is going to be equal to any pair of corresponding sides. So I'm going to put corresponding sides of those similar triangles. So for instance, I could say side AB on top. What's its corresponding side? Yeah. So this side AB over side EF would be a valid proportion. So it's kind of interesting. And I can use any pair of sides. So not only could I use AB over EF, could I also use BC over FG. Okay, so because they're similar triangles, I can pick any pair of corresponding sides. We also have angle bisectors. Angle bisectors, you can see we have little arc marks up here. These little baby angles have been bisected here. So this QS happens to be an angle bisector, and UW is also an angle bisector. And again, we have these similar triangles. I'm going to put a little similar in there just so we know. PQR is similar to TUV. So we already have similar triangles. We've got this extra special segment going on in there. And so I can create a ratio using those angle bisectors. So I could say QS over UV would be proportional to, give me a pair of sides of our similar triangles. Yes, the whole side of the triangle, PR over TV. All right, that's an option. That whole similar side to this whole similar side. And again, we could use other sides as well. We could use QP over UT. We could use QR over UV if we wanted to. All right. And then last we have medians. A median goes to the middle of the opposite side. A median, so you can see our side GI got bisected. So that segment was bisected. J is a midpoint. So here we have a median, and NL is also a median. And once again, we can use that median to create a proportion. Since I know my triangles are similar, I could say JH over NL is going to be equal to any pair of corresponding sides. So give me a pair of corresponding sides.
G and K?
Those are angles. So I need pairs of sides.
Oh, GH.
Okay, so we could say GH and KL. That's an option, GH and KL. Or I think, Clayton, did you say GI and KM? Yeah. And also HI over LM. So any pair of corresponding sides. And again, that just goes back to the nature of similar triangles. All right, they just create proportions all over the place. So let's just practice a little bit. These are not sort of the big focus here. Here, given similar triangles, solve for x. So on number 1 here, right off the bat, they're telling us we have similar triangles, and this is really, really important. These triangles are all twisted and rearranged and rotated. They are not oriented the same way, so this is really tricky to look at. And so I know, let's see, what kind of segment is SW and DF? What are those? Medians, yeah. They are medians. So I can use those medians. So I'm just going to go left to right here. So SW, which has a length of x, over DF, which has a length of 15. And then I need to find any pair of corresponding sides. And since these triangles are rotated all crazy like, I'm going to use the statement. So give me a pair of corresponding sides from our little similarity statement. SU and DC, sure. SU, oh, what is SU? SU is 19.2. So SU and DC are similar, 19.2 over 24. And again, that just came from the similarity statement. Could I write another one?
TU and CE.
Let's see, TU and CE, yeah. So TU would be right here. Oh, I don't have a length on that, so that's not going to be too helpful. But technically, if there was a length there, I could, but I don't know what it is, so there's no numbers on those. What else could I do? ST, let's see, ST, those are the first two letters. ST is right here, and DE, yeah, right there, DE. And so I could do that. I could do 16 over 20. So we have options here, all right? Do we know how to solve for x?
Yep.
Cross multiply? All right. Cross, yes, x is 12. Cross multiply, x equals 12. Great. Let's look at number, what kind of segment here is DC and FH? Angle bisectors, yes, these are angle bisectors. All right, so if I did DC, which is 32 over 24, what can I set those equal to?
AC.
Yeah, AC. I have that information. I have information about AC, and then that's going to correspond with EF, which is right there. So 38 over X. And of course, I think you know how to solve for that. And then on number 4, they're giving us kind of a weird little picture here, but what is this vertical right here and here? What are those called? Those are altitudes that fall outside the triangle. So I'm going to do top then bottom, so 12 then 15. All right, so then altitudes could correspond to what information? So should I do 42 on top? No. X on top. Okay. So because I went top then bottom, I have to go back to the top. I have information about PQ here. So there's PQ, and that's going to correspond with UT. So that's 42. So X over 42. Again, I went top then bottom, so I have to do that same motion, top then bottom. Got to keep the same pattern. All right, you good? All right, turn the page.
Oh, let's go.
All right. So here we have the angle bisector theorem. Now this is only one triangle versus what we were just looking at where they gave us similar triangles. So here we only have one triangle, but it turns out that an angle bisector in a single triangle separates the opposite sides into two segments proportional to the lengths of the other two sides. So once again, I'm going to get, if I have these angle bisector here, I'm bisecting an angle, I get some proportionality statements here. So we have two segments that are created from this angle bisector. So that is AD and DC. So I have two segments there that get created by my angle bisector. It turns out that they're proportional to the other two opposite sides. So AD is over here on the left. So I'm going to use this left side of the triangle. So that's side AB over BC. Now, the way that I actually think about it for myself is if I have an angle bisector, I see this little, here's my little angle, and I go dunk, and it hits like a billiards ball, like a pool table. This side, then its opposite side. So I write it myself when I do this, AD over AB is equal to, and it hits the opposite side and bounces, DC over BC. So when I do this, I draw this little like W sort of shape. For me, that's just how I set things up. Are these the same?
Yes.
Yeah, they are. If we cross multiply, we're multiplying AB times DC, and here again, we're multiplying the same AB times DC. So it's just however you want to set that up. There's lots of ways. So for example, first of all, really important, we read the directions. KM represents an angle bisector. So I know that I have these two angles are congruent, and so I can use my angle bisector theorem. How do you guys want to set this up?
4.8 over 12.
Hey, you did it my way. Sweet. So I go 4.8 over 12. 4.8 over 12 is equal to? Yeah, X over 18. And again, that's just how I see my little dot bouncing like a billiards ball off the sides, and I don't know why I see it that way, but that's just what I do. And again, there's other ways to set that up. Also, you could have done something like 4.8 over X is equal to 12 over 18. And again, you'll still end up getting the same answer. X turns out to be 7.2. All right, how do you want to set up number 7?
40 over 54.
Yeah, again, we have our little angle bisector. And again, 40 over 54 is equal to 36 over X, and cross multiply. What should we do on number 8? Subtract, yeah, 39 minus 15, because we need our little baby segment piece. What is that, 24? All right, so 24. And again, they left off the K. That's so adorable. So again, we have our little angle bisectors here. So how should we set this up? You did it that way again. It works well, doesn't it? Like, I don't know. I like the visual. 15 over X is equal to 24 over 36. Again, this is kind of nice because you can reduce your fraction first if you want to, but again, we have calculators, so who the hell cares?
9 is plus.
Oh, interesting. Let's do 9 because this is really good. So we did just subtract to get 24. On number 9, my whole thing is x, and I have a piece that's 12. So how do we figure out ML? X plus 12 or x minus 12. Very good. The whole thing minus the 12 gives me the leftover bits. This is actually x minus 12 for this little piece here. So we are subtracting just like we did here, except x is, we don't know what that number happens to be yet, okay? So once again, I can set this up using my little bounce method. So x minus 12 over 30 is equal to 12 over 18. And again, you can cross multiply and distribute and solve. Do I need to do that one, or are you good? Okay, great.
I just want to understand,
Yeah, how to subtract that. Yeah, that was a good question. All right, you guys have delta math, and I'm going to explain your final exam.